Hello viewers, Electric Circuits question 10. For this circuit, find the total resistance and the current through the battery and each resistor. Therefore, find the power output of the battery and the power consumed by each resistor. So we have an 11 volt battery, and there are three possible paths that an electron can flow through. The first path would be through both 2 ohm resistors. The second path would be through the 1 ohm resistor and this 2 ohm resistor, and the third path would be the outside loop through the 15 ohm resistor and the 2 ohm resistor there. Either way, it's going through that 2 ohm resistor, which puts that resistor in series. So therefore, the total resistance is going to be 2 ohms plus the parallel part, which will be 2 to the negative 1 plus 1 to the negative 1 plus 15 to the negative 1, all of that to the power of negative 1. And if we calculate that, we get 2.638 ohms. So that's the overall resistance of the circuit. Now we need to find the common current, so the current through the part of the circuit where the battery is. So ICOM is from Ohm's law, V over R. Voltage of the battery is 11 and the total resistance is 2.638. Calculating that gives us 4.17 amperes. So that's 4.17 amps going through the battery. Now we need to find the voltage going across each of the resistors, which is going to be the same. But in order to get that, we need the voltage that is across the 2 ohm resistor, because what's left over is going to be the voltage that the resistors experience. So therefore, the voltage of the 2 ohm series resistor is I times R. We now know that the current going through it is 4.17 amps times its resistance is 2, giving us 8.34 volts. Okay, so we've got the voltage across this resistor. It's consuming, as we can see, most of the 11 volts. What's left over is 11 minus 8.34. So the parallel voltage is 11 minus 8.34, which is 2.66 volts. So that's the voltage across these three resistors. Now let's work out the current there. So the current across the 2 ohm parallel resistor is going to be V over R. We now know that the voltage across it is 2.66 and its resistance is 2, giving us 1.33 amps. Now similarly for the 1 ohm resistor, it's the current passing through it is V over R, which is 2.66, this time over 1, giving us 2.66 amps. And lastly, the current through the 15 ohm resistor, same formula, V over R, same voltage, 2.66, divided by its resistance is 15, giving us 0.18 amps. So the three paths, 1.33 amps plus 2.66 amps is 3.99 amps plus 0.18, gives us 4.17, gives us the common current. So that has split up exactly as expected. So we now know the current passing through each resistor. All that remains is to find the power output of the battery and the power consumed by each resistor. So the power of the battery is I times V. Now we know that the current passing through the battery is 4.17 and the voltage of the battery is 11, which gives us a power of 45.87 watts. Now let's work out the power consumed by each resistor. So the power of the 2 ohm series resistor is I times V. So we know that the power, that the current is 4.17, and we know that the voltage is 8.34. So 4.17 times 8.34 gives us a power consumption of 34.8 watts. Now let's do the 2 ohm parallel resistor, which is I times V. We know that the current passing through that one, we found that to be 1.33, and the voltage is 2.36. And if we calculate that, we get a power consumption of 3.54 watts. Then we do the 1 ohm resistor. Power consumption there is I times V. Current passing through it is 2.66, and we're multiplying by the voltage, which was 2.66, and that gives us 7.08 watts. And then the power consumed by the 15 ohm resistor, again I times V, which is, the current there was 0.18, and we're multiplying by the voltage is 2.66, gives us 0.47 watts. So hopefully the total power consumed by the resistors matches the power of the battery, at least to within round off. So we have 34.8 plus 3.54 is 38.34, plus 7.06 is 45.42, plus 0.47 is 45.89. So close enough to 45.87 to within round off. Thanks for watching. Over and out.